Uh, so I'd like to welcome everyone to this month's version of the ReproNim webinar. Uh, and I guess you can go ahead and share a screen, Daniel. We are pleased to have Daniel AC here with us today. He's a software developer within the Neuroinformatics Research Group at the Harvard Center for Brain Sciences, with previous stops at Brigham Young University, UC San Diego, and the University of Michigan. Daniel's work focuses on open source and open science initiatives, along with debugging his own code. As we can see from the attendance today, in addition to debugging his code, he spends time chasing and being chased by his 3 young kids. Before I pass the baton to Dan, I wanted to take a moment to both admire and recall the overall efforts of the Neuroinformatics Research Group in its various locales and its leadership with Randy Buckner and Tim O'Keefe. Randy introduced me first to XNAT back in what must be the early 2000s, and ever since then, that group's collective attention to the importance of data management, open source, and end user-centric products and sort of end-to-end processing has been, groundbreaking. So I just wanted to acknowledge that at the beginning and turn the floor over to Dan.
Okay, thank you so much, David. And hello to everyone. I'm so excited to be able to present today on what we've been working on, this diffusion imaging quality assurance pipeline. So I look forward to talking about the work, and also really looking forward to receiving feedback from everyone. This is something that is in no way set in stone. We want to continue to develop and improve this. But that being said, we hope that right now it can be useful for many folks. And we're just really excited to kick this off and release it to the community. So Tim alluded to this a little bit already, but the Neuroinformatics Research Group already has a number of pipelines that have been developed over the years. So we've got our bold QC for fMRI data, bold data, NAT QC for T1 data, T2 QC for T2 data. And these are excellent, very helpful pipelines that all kind of encompass this goal of real-time data quality checks. And we were happy to add DWI-QC to this now, which is what I'll be focusing this presentation on today. So I'll just go ahead and jump into this. I'll give a brief overview here of the presentation, kind of what to expect in the different sections that we'll cross. So first, we'll talk about the why of DWI-QC, why we decided to do this, why we felt this was important. And then we'll overview the makeup of DWI-QC, the anatomy, if you will. And then we'll take a look at some of the DWI-QC output, what to expect, what you'll see, and then also a brief overview, a very high-level conceptual overview of using DWI-QC. We'll discuss some strengths and limitations of the software, and then again, briefly look at the documentation, just to give folks an idea of what it looks like, what's there. Talk about some future directions, things we hope to do in the coming weeks, months, and years with DWI-QC. And then perhaps most importantly, get some thoughts from everyone, feedback, questions, comments, all those things. Very much looking forward to that section. But that being said, I hope that everyone will feel free and empowered to ask questions along the way. I'll stop periodically, but please don't hesitate if you have a question or a comment to say something, or to do the hand raise on Zoom, whatever you prefer. So we'll just jump right into it here. The why of DWI-QC. So there's been a growing interest, increasing, not quite exponentially, I would say, but an increasing interest in diffusion imaging. And there's the technology that has come a long way, and it's much more feasible for folks to collect diffusion imaging in a given study. So because of these advancements, it's even easier now for folks who are not necessarily just focused on diffusion imaging data per se to kind of tack on diffusion acquisitions as a part of their studies. So it may not, like I say, may not be the focus of a study, maybe an fMRI study, but because of the growing interest in diffusion imaging, its capabilities, that we're seeing more and more that diffusion imaging is being tacked on to otherwise focused studies. So there's a lot of interest here and lots of very useful standalone tools that have been developed. We're familiar with FSL tools, MR tricks, and then larger pipelines that kind of integrate all these tools like prequal or QSI prep. However, we felt that there was a kind of lack of cohesion amongst all these tools, that there's a lot of wonderful tools being developed and that are out there available, but they're kind of disparate. They don't really connect very well all the time. So we wanted to bring them all together and provide this foundational computational support for diffusion. So this is kind of where we're at. We're trying to address a need, fill a hole, because folks want to do diffusion imaging and analyze it, but there's not necessarily one place to go for it. So with that being established, we'll talk about the makeup, the anatomy of DWI-QC. So it's written in Python, primarily in 3.9, and it needs that's the minimum dependency for it as well. But all of the functionality of DWI-QC is accessed through a command line tool aptly named DWI-QC.py. So it serves essentially as a wrapper of two diffusion imaging pipelines that I already mentioned, prequal and QSI prep. And we included both of those as to try to hope as a catch-all for any kind of different goals, research questions an individual, a group may have. And I'll get into that more later. These respective strengths and weaknesses, they balance each other, and hopefully we can get it all with having both of them. So by running both of these pipelines, DWI-QC will run them and then aggregate their output into one cohesive report that gets displayed on XNAT. It's not a hard and fast rule that one needs to use XNAT with DWI-QC, but it is an XNAT plugin and has a landing page and all those things and lots of tabs to look at, which we'll take a look at, but it integrates nicely with XNAT. So these are containerized versions of prequal and QSI prep, and along with some other containers that we'll talk about more here, but this is just kind of an overview. But I want to talk more about these containers. So we've got prequal, QSI prep, and then containerized versions of FSL and Chromium. So these containers are kind of, there's different versions that are out there, but we wanted to facilitate the installation, the download of these containers, the proper versions that we are using, that we've normed things on. So we have an install containers mode for DWI-QC. So it's a simple command that users can use that will download the containers from a website where we're hosting them and download them to a user-specified directory on the local file system. It is important to note that we've made some key changes to particularly the prequal and FSL containers. They're kind of customized versions, if you will. We haven't changed anything about the actual data processing, but we've changed just how the reports are generated a little bit. So nothing has been changed in a functional way, just in trying to make the output a little bit easier for us to work with. And as I note here, the 30 gigabytes of storage space would be necessary for downloading the containers. So I will pause here if there's any questions or comments up to this point.
Quick question, in the containers, does it matter if it's Docker or Singularity, or can you go between Docker on someone's desktop and Singularity on someone's HPC or something like that?
Excellent question. So these containers, they are Singularity, and we do, and so, like I said, we did make some changes to these Singularity containers. So these specific Singularity containers should be downloaded for the use in DWI-QC because of the changes we made. So yeah, Singularity would be what we'd use. Good question.
And I guess related to that, while I'm asking, as you sort of mentioned, this is at one level envisioned within the XNet environment. So again, we're an XNet user at our group at UMass, and I imagine that once a DWI, a compliant data set comes in, this would launch somehow via the Singularity containers to like a high performance system. And again, Christian knows the more details of this, but again, we presumably do that through Singularity containers as well onto the high performance backend. So it's not really at this level intended to be sort of a user on their desktop type of tool. Is that the right, or is it?
Well, yeah, so it's at this point, DWIQC has not been containerized. It's not integrated into XNet Container Service. And the reason for that is we've got this problem with, we've got prequal and QSI prep. And when we have a Singularity recipe file that we try to, want to build prequal and QSI prep within this one large container, there's some dependency conflicts between the two. So we can't build them within the same container. So that's why we have them kind of modulated into individual containers. And then this DWIQC Python code is meant to be used from the command line on an HPC system, but that it accesses the prequal QSI prep containers as standalone containers. So it's not all been wrapped up together. That's something we want to reconcile, these dependency issues between the two. So unfortunately, it's not like you say on XNet. It won't be just kicked off nicely like like these other pipelines that we have. But there are ways around it, but it's not quite as seamless as those other ones.
Okay, thanks.
Yeah, that's an awesome question.
I have a question about the licensing. So I see you use the Harvard license, which is fairly open. You can just need to keep the copyright. But since you include FSL, which is not a very open license, it kind of limits the use for commercial purposes. Is there a way to get around that? I mean, to not use the FSL part?
That's an excellent question. As far as I understand, so FSL is being used by Prequal and QSI Prep, and I'm not sure what licenses they are using. But to be perfectly honest, I'm not sure. Maybe Tim, would you be able to speak to that a little bit?
Yeah, looking at the FSL license, yeah, you're right. You're permitted to use it for non-commercial use. So I don't think it would be very easy to untangle FSL from this pipeline. So yeah.
Okay.
Yeah.
I think if you want to use FSL in a commercial application, or if you want to use DWIQC commercially, yeah, you're right. The FSL license would probably get in the way of that.
Yeah. Okay. Thank you.
Yeah, thanks, Tim. I wasn't sure about that one.
And just as an aside on this topic, we've been running into a number of folks who, while they love FSL and FSL's diffusion toolkits, are actually rewriting gobs of it just to try to get around, that licensing issue. So it's a problem that is being worked. I mean, is a problem for everybody. So yeah.
Yeah, it's good to know. But who's doing that? Who's leading those efforts?
Well, there's a diffusion tool. Well, it could be a long discussion of that, and then where does that DiPi and things like that fall into all of this? But in the case I'm thinking of is Brian Avance, and the from the Ants fame was working with us on trying to redo some things. It's like, oh, why are we doing FSL? Oh, why are we doing DiPi? It's like, oh, get around license issues and things like that. So yeah, so licensing matters, and the conflicts it can cause sometimes requires things to be rethought.
Mm-hmm. Yeah.
That's good to know. We'll want to keep our finger on the pulse of that one. Yeah, great questions. Anybody else have a question or comment? Okay, we'll forge ahead here. So I want to talk about the rationale for using both QSI prep and prequal a little bit. They are excellent in their own right, and they draw very heavily on FSL and Matrix, these tools that we're familiar with. They have some kind of homemade things as well, which I find useful. So they're excellent pipelines, and we wanted them both, like I mentioned, to leverage their respective strengths. Particularly their experimental design assumptions, and we'll get into that. But we felt that by having both of them, we could catch almost all use cases and experimental designs and different things that people will prefer depending on research questions and resource constraints and availability, things like that. It's worth noting that QSI Prep is a BIDS app, and it kind of was developed with a similar ideology to other BIDS apps that we're familiar with. So if you've used QSI Prep, or when you look at the output, it'll feel familiar to users that have used FMI Prep or MRQC as well. Now, prequal was specifically made to address some of the weaknesses that they felt QSI Prep had, and one could reasonably argue that that left it vulnerable to other flaws, other weaknesses. So it just strengthened the argument in our minds to include them both. So hopefully we can get the best of both worlds here, at least as close as we can get in science. But like I said, I want to touch more on what I see as one of the biggest fundamental differences between the two is the experimental design assumptions. So because of, like I mentioned, this recent interest in diffusion imaging, there's not much consensus. People are kind of doing lots of different things, which is good. It helps the field move forward, but it also presents challenges for those who develop the software for analyzing this data. So as it relates to field map acquisition, this is where things differ quite a bit across different studies and different research groups. So some studies will have a primary and reverse fade encode direction field map for every single main, I'll call it, diffusion scan. Every a diffusion scan that's especially kind of long, something in the ballpark 75 directions up to 120, anything in that range, kind of longer diffusion scans, they will have a dedicated field map in both the primary and reverse phase encode directions. So here's an example of that. We've got these two field maps, one collected in posterior anterior direction, other in anterior to posterior, and then immediately following it, a 103 volume diffusion scan. So what's meant, the susceptibility distortion correction top up is meant to be run using these two field maps to run the correction on this diffusion scan. So it's the 2-for-1 model, 2 field maps for 1 diffusion scan. And this is how QSI Prep approaches the analysis. It kind of assumes this and analyzes the data accordingly. Now there's the other way that's, there's not just 2 ways necessarily, but it kind of falls into these 2 camps for lots of studies, is acquiring 1 reverse polarity scan and then the V0 volumes being extracted from the primary diffusion scan to run the susceptibility distortion correction. So lots of times these main diffusion scans are much shorter. There's maybe 15 directions or 20 directions as opposed to the longer 7,500 directions. So here's an example of that. We got this reverse polarity scan, and then this SBREF, which is not considered as part of the analysis here. And then a main diffusion scan, another SBREF not considered, and then a second diffusion scan. So the way prequal will do this is it'll combine this, if it's kind of assigned to, when you run this reverse polarity scan, it's understood that you will apply this B0 volume, this distortion correction, to these 2 diffusion scans, and then these 2 diffusion scans will be combined, and rather than being a 15 direction scan and a second 15 direction scan, they're now a 30 direction scan. And you can aggregate these across as many diffusion scans as you want. It's up to the study, the research group, whatever it is. But this is how prequal approaches it. regardless of how long these scans are, how many there are, it will, if they're all the parameters are the same, the acquisition parameters are the same, it'll combine them all into kind of one mega diffusion scan. So that's the biggest difference between the two, is how they analyze the data. And this impacts the metrics that it spits out, all these key things down the road. And it's worth having them both to kind of catch all preferences. So I'll pause here, see if anyone has any questions regarding the QSI prep prequal approaches. So we will forge ahead then. So we've got these two pipelines that make up DWI-QC. So now let's take a look at the output a little bit. And many of you may be familiar with QSI prep and prequal output already. But this is how we've organized it onto our XNAT landing page. So in this scenario, you run, your data gets uploaded to XNAT, and then you run DWI-QC on it, and then upload the results to an XNAT session. So this is one session for a subject. And this landing page consists of what many folks that we consulted considered to be the most important things you want to look at right away for diffusion scans. So we've got SNR and CNR metrics and motion metrics on this left panel here, and then FA maps, ND maps, and then you can scroll down. This is a screenshot, so you can't, I can't scroll down, but there's motion plots, brain masks, outlier slices, all those kind of things. But kind of, we chose the images and metrics for this landing page that we thought people would be most interested in seeing right away after the results are in. So I'll go through each of these tabs and just show what it looks like at the top level. You know, like I said, we won't be able to interact with it, but you'll get an idea of what's there. So the prequal report, this is a PDF that prequal generates, and it's several pages long, has lots of nice images and graphs, all the information that was gleaned from the prequal analysis. And then we've got EdiQuad, very similar, a PDF report with the metrics that EdiQuad spits out. And if you're not familiar, EdiQuad is an FSL tool that runs, it's a quality assurance tool that runs on the output of the FSL Edi command. So in this case, it's on the output of the prequal FSL Edi that gets run within prequal. And these are all the metrics that it produces. And then we've got the QSI prep report. And this will look familiar, like I said, for fMRI prep and MRI QC users, that QSI prep generates, you know, these row by row images and sometimes these GIFs that move and change. You can see registration, you can see susceptibility distortion correction changes, all those types of things as you scroll through right here on the web browser on the QSI prep report. And then this manual QC tab is for researchers who can go through, and it's a report of such that you can look at in a CSV file that you can download from XNAT, just to compile a user QC. And then finally, these are all the stored files on XNAT from the QSI prep and prequal output. So lots of things, lots of helpful things here, things that are these QSI prep reports, EdiQuad, prequal that are found here. They're found here as well. You click on them and it'll download to your local machine or wherever you're accessing XNAT from. So that's the XNAT portion of what the output looks like. Does anyone have any questions about this or comments? Okay.
I'm sorry, slow to get to my thing.
Oh, sure.
Just double checking once again that if one is an XNAT user, great. And again, it's probably something we talked about a minute ago, but if one didn't happen to be an XNAT site, then what?
Yeah, that is an excellent question. That is exactly what I'm going to talk about next. Thank you
Excellent.
for the
Okay.
segue. Yeah, it is not a hard and fast rule to use XNAT. With DWIQC, you are allowed to use it outside of DWIQC, or outside of XNAT, excuse me. So I will go over here the directory level output. This will be all the exact same output that you just saw in XNAT, except there's no pretty pictures and kind of aggregation of all these metrics and images. So I'll go over it quickly here. So we've got the output directory, which is user specified when DWIQC is run. And then we'll just go down the files tree here. So there'll be a derivatives directory underneath the output dir, and then it'll split off into a prequal and DWIQC output directory. So they largely follow the same structure for a couple of steps. You'll get the subject name and then the session for that subject. And then this will be for prequal, this is where it ends under the outputs directory. That's where all the reports, all the metrics, everything goes. And then QSI prep output has one more step into QSI prep. That's just the nature of how QSI prep was written. But this is how it gets presented in this file structure. So it gets buried a little bit, but hopefully it helps keep things organized. And we'll just look quickly here at an example of a prequel output directory. So there should be 11 subdirectories and one text file. So I'll save the trouble. That's what this one has. But the kind of directories I want to call your attention to are the PDF directory right here. So that's where you'll find the PDF report from prequal, just the same as the one that I showed on XNAT just a few minutes ago. So you can download that, open that. And then this PNG directory just contains all of the component images that get aggregated and put together into the PDF file. So if there are individual images that you want for a paper or for whatever you need, you can find them there. So you don't have to try to cut them out of the PDF. And then the EDI directory, like I mentioned earlier, the EDI, FSL EDI output, it gets put here. And this directory contains lots of files, but there's one most crucial one that will end with .qc. So here's an example, subject session.qc, and that's where all the output will ultimately go. So you got all of these PNG images that are useful to look at. And then crucially, this qc.pdf file, that's the EDI-quad PDF that I showed on XNAT that puts all these images and metrics together in one place. So that's useful to know. And then this qc.json contains all the metrics that are found on that PDF report, and you can access them individually. So that's what it looks like in a directory structure for prequal. And then for QSI prep, it's a bit more straightforward. There's fewer files and directories, but the ones that I want to call your attention to are this QSI prep.pdf file, and then sub.html, and then sub embedded images.html. And they all are essentially different versions of one another. So this default one, sub.html, is the default output from QSI prep. It has all the GIFs, metrics, images, everything that you're familiar with for a bids app pipeline. However, the problem with that is that if you're going to open that file, it depends on you opening it within this directory that it can access all of the output images from QSI prep. So you can't just pull out this HTML file and open it somewhere else on its own. You won't see any of the images that are supposed to be there. So that's why we created the embedded images. And I mentioned the use of Chromium earlier, and that's just a tool that we use to essentially embed the images and GIFs and all those things that come from QSI prep into the HTML file. So you can download just the embedded images HTML file to a local machine, and you open it anywhere, and it'll have the complete report. And the QSI prep.pdf file is the same way. The only difference is that it doesn't have the moving GIF images, the images that can change. So we decided to put that there just in case someone had a preference or a need for using a PDF. So this, and I guess one more thing I'll note is this qc.json file has all of the metrics that are generated from QSI prep and that are put into the report, but it's a good place to look if you want to extract specific metrics. So that was a lot of information, a lot of directory screenshots. Does anybody have any questions? Anything I can clarify about the structure?
I can't help myself. I will jump in on the DWIQC.json, in part because metadata is so important, and machine readability of that metadata is so important, and being able to aggregate and discover, data based on metadata. And these JSON files and the, bids and derivatives and these types of things are great start in that direction. If there, and this may not be something we'll solve, in the question, but it's more a statement maybe that if there is standards that the descriptors or that the fields can refer to, so that if QSI prep generates one set of metrics and some other similar tool generates the same metric, but from that tool's point of view, making sure that we have sort of commonality or ways to crosswalk, the different outputs from things is often perhaps derived from the way we tag or make versions of this JSON types of representations. So I'm mostly just going to say that perhaps that's something we can talk about in the future, is how to make those representations even more machine actionable or semantically tagged, as well as the whatever. Anyway, just wanted to point that out.
Yes, no, I greatly appreciate that. Wholeheartedly agree. There's having lots of tools is great, but having a way to compare them and look at them side by side, see and understand what they mean. Definitely agree. Thank you. So we'll go ahead and move on now to a very high level overview of using DWIQC. So like I said, it is written in Python, but you don't have to be a great Python user to actually use it. But there is a big assumption that's made, and that's familiarity with the command line. You will probably struggle a bit to use it without some command line familiarity. You don't need to be an expert by any means, but being familiar with it, I would say, is essential. And in terms of dependencies, there needs to be Python greater than or equal to version 3.9 on the computing system that's being used. Otherwise, there will be some cryptic error messages that are a result from import statements, circular imports that we use. So it's not going to necessarily break anything now, but it can cause some confusion. And then, skipped ahead. And then Singularity needs to be installed on the computing system as well, because of our use of Singularity containers. So that is a must as well. And like I said, exposure to Python is helpful, not necessary though. All the Python commands are relatively simple. It can get long, but it's not copious and is spelled out in documentation with lots of examples and templates and things like that. And then I'll just add that being familiar with an HPC system is very helpful. If you're not familiar with an HPC system and not familiar with Slurm or whatever scheduler your HPC system is using, it could cause some difficulty, could be a bit of a barrier, but that's something that local university ITs can help with, or organizational ITs can help with. So I just wanted to say that there are some assumptions being made here and some things that need to be a part of your computing system. So I want to talk about installing DWIQC. I've talked about it a little bit, but it's not been containerized. So because of that, it needs to be installed through a pip command. It's a Python library manager. And it's as simple as pip install DWIQC. And that will start the download of DWIQC to your local environment. I would definitely recommend using a virtual environment for it. It is not a hard and fast rule. It's not strictly necessary, but I tend to think that it's helpful to do so, especially as different versions can come about. Knowing exactly what version you've been using and having a virtual environment to kind of keep you grounded and organized in that way, I think is very helpful. There are a handful of other packages that DWIQC depends on, but it's nothing extensive. It requires less than 5 minutes of total install time. I'm not sure why this is. Oh, there we go. There should be a link under here, but I'm not sure what happened to it. So here's one. This is from here on out, I'll have a link here to the documentation, specifically what I'm talking about. So just keep an eye here as you want further details on something. This link is available for use for future reference. So I want to talk about here, after getting it installed through Python, the pip install DWIQC, there is an install containers mode, which I alluded to, that's essential for running DWIQC for the first time. If you've never run it, if you've never installed it, this is an essential step because it will download all of the necessary containers that we use to the local file system. So it's a simple command. It looks just like this: DWIQC install containers, and then this argument install location is the path to your file system wherever you'd like to store the containers, the pre-qual container, QSI prep container, FSL, and Chromium. And like I said, it takes 30 gigs of memory, so you just want, or of storage. So you just want to put that somewhere. But that's doesn't present a problem, hopefully. I will say you don't have to have this install location argument. The default location is your home directory .config DWIQC containers, which is make any IT administrator upset to have you store large files in your home directory. But it's not that's where it'll go if you don't specify the install location. And if you do specify an install location, a symlink will be created between your install location and then home directory .config DWIQC containers. So that's just there as kind of a fail-safe, as a backup, so that it can, if DWIQC can't find the containers, if it's not passed as an argument when processing the data, it'll look here for a symlink to find them. So as just kind of a backup there. So with the containers installed and DWIQC installed, kind of ready to go, now comes the matter of getting the scans downloaded that you want. And one helpful way to do that is tagging scans on XNAT. So I'm not sure how many folks are familiar with this, but looking at this example of three scans stored in XNAT, this over here on the far right is the notes field. And we've decided to utilize the notes field by tagging scans. So we call them tags because of this hashtag here, but as a way of labeling scans, so that when we want to download data to an HPC from an XNAT instance, you can find exactly what you want just based on the tags. So there are a couple of ways to do this. One is through the XNAT interface. It can be a default. As soon as data gets archived into an XNAT instance, you can tell it that if it has a certain series description and it has a certain file description, if it meets those criteria, then tag it with DWI_FMAP_AP, for example, and it'll do that automatically as data is archived. Another option is to use the XNAT Tagger Python package, which we developed as well, and it can be integrated into DWIQC. There's an argument that you can pass called run tagger, and it requires a little bit more than that, but I just wanted to put that out there that it's an option. to tag your scans. And it's really helpful, in my opinion, to tag scans, because then you can, when you want to download data from XNet, all you have to do is tell DWIQC what tags to look for, and then it will download those scans only. So I'll pause here, see if there's any questions or anything I can clarify for anybody. Tagging can be a little hairy.
Yeah. Surprise, surprise, it's me again. So on the one hand, you earlier talked a little bit about it, this being a bids app like design to it. And now I feel like some of this tagging is the types of things that a bids version of a DWI, data set might have, like in the field maps directory, the various AP types of things. So is it correct kind of think of this tagging as a way to sort of map between where things might live in bids world and the way it's stored within XNet?
Yeah, it can certainly, that's an excellent observation. It can certainly be used that way. It doesn't have to. These scans, you could tag it, you could call it anything, but it is a helpful way as you download things into bids format. And you're very good at helping me segue into my next topics. So I hope to answer this question further here.
Thanks.
Yes, no, thank you. So with Git mode, it uses, well, I'll back up before I answer your question. So when it comes to the Git mode is a way through DWIQC to download your data from XNet to the whatever file system you're on, your HPC or local file system, whatever you want to call it. And it uses the excellent Yaxle package for that download, developed by my esteemed colleague, Tim O'Keefe. And it gets downloaded into bids format, into a user-specified directory. So how it does this is through a YAML configuration file, and that determines which scans get downloaded, what they're called in the bids directory. Oh, I'm not sure what's going on here. Wow. I'm sorry. What they're called in the bids directory, and then where they get placed in the bids structure. So to your point, David, this is how these things are connected. So which scans get downloaded, you don't have to use tags for this to tell Git mode which scans to download, but it is helpful. And you can name them such that you know exactly how they're going to show up in bids, in the bid structure, what they're going to be called, and where they'll be placed in that structure. So I want to illustrate this a little bit with an example of this config file. So in this example here, this is what you'll feed, something like this. You would feed into Git mode to tell it, first, what am I looking for? So this tag is similar to what we saw here. So it can be anything. It's whatever you've decided to call it. Don't get too hung up on this. This is on this hairiness. It's a regular expression, which anyone who knows that they're painful but so helpful. But it'll look through all the scans, and if a scan in the note field has something that matches this, DWI_main_A, and then a run number optionally. If it has anything like that, it'll say, okay, this is a scan that I should download. And so it finds it, it locates it, and then it uses the rest of this information to create the name of the bids, of the file according to bids specifications. So the bid subdirectory that this one should go under, a scan that has this tag should have the DWI subdirectory and a DWI suffix, and then what direction was it acquired in, anterior to posterior, and then if you want to add acquisition group, you can call that whatever you'd like. And so if you do that, when it gets downloaded, assuming this is a bid structure, this is under the DWI directory. So you've got the subject, session, then acquisition, A, the direction, anterior to posterior, run, if there's a run here, we'll call it run 1 or whatever it is, and then dwi.nifty.gz. So this is how the tags and downloading the bids format gets connected. You tell all the information here, and then get mode using Yaxel will download it to your specified directory following your specifications. So this is an example for diffusion for field map. It's very similar. The tag here, it'll look for a scan that matches this tag. And then once it finds it, it'll put it into the fmap directory, the posterior to anterior direction label, and then acquisition group A in this example. So very similar, subject session, acquisition group, direction, run, EPI now in this case. So I hope that answers your question a bit, David, of how these connect.
Yep, thank you.
Okay. Anyone else is feel free to chime in anytime. Welcome questions.
Yeah, I was going to say you also have to include the sidecar there, and then the intended fors and all that.
Yeah, so that's a great question. So the sidecars, but what Yaxel will do is download the data from XNAT in DICOM format, and then run DCM to NIX. So then the sidecars and the BVAL and BVEC files will get generated there as part of DCM to NIX. And then what's really helpful is this having an acquisition group that DWIQC will look to match acquisition groups between the fmaps and the DWI files. So if they match acquisition groups, then the intended for, like you mentioned, will get added to the this field map JSON file, just JSON sidecar will get added there and match with whatever this acquisition group, whatever the matches within the acquisition group are for the DWI scans. So does that make sense?
Yeah, that's a great way to do it.
Yeah, this was born out of necessity of so many different ways that one could approach this. So this acquisition group gives the user lots of flexibility, we hope, in how these fmaps and main DWI scans get matched up with each other. So yeah, thank you for asking.
Thank you.
Okay, so we'll march on here. I just wanted to provide an example of running get mode. So requires 4 arguments, the label from XNAT, and it's worth noting that get mode is only applicable to people who have an XNAT instance. It's not useful if not. So you need the label, the session label for that's found in XNAT. And then the bids dir, that's, I mean, you could call it the download dir, but the bids dir, that's where the user will specify where they want the data to come from XNAT. And then an XNAT alias, and this is created using Yaxel, which I mentioned earlier. And to be brief about it, it's a way of storing your XNAT username, password, URL, all those things in one file, and you can access that file with an alias. So you could call this XNAT alias for a particular XNAT instance. You know, if it's nitric, you can call it nitric, and then it'll store your credentials. So I don't want to get too much into it. The documentation is very helpful on this. And it's not exactly necessary to use the XNAT alias argument. You can pass your username and password and URL and all those things if you prefer. But I would recommend this. I think it makes your life much easier. So thanks to Tim for this one. And then my computer's lagging on me a little bit here. Okay, there we go. So then the last argument that we need is the download config, and that's just referring to like a config file that contains something like this. And the documentation has an example of a full-fledged config file. So you'll just need to pass a path to that. So this is what it would look like as on the command line. And so that's just there for your reference. So that's get mode. That's how you get the data from XNAT. Now we'll move on to process mode. So this is where you actually get to run the DWIQC pipeline. So for this part, you don't have to have an XNAT instance. It's okay if it's not from XNAT, but you can still run process mode on non-XNAT data, but it just needs to be in BIDS format. Without it being in BIDS format, it'll get upset, primarily because of QSI prep requiring BIDS. Prequal does not, but QSI prep does. So we've made it such that DWIQC won't run unless it's on BIDS data. So this is where it gets to run. By default, both QSI prep and prequal get run. You can turn them off, one of them off, if you'd prefer. There's an argument for that, which gets explained more in the documentation. But you don't have to run both if you don't want to. QSI prep takes longer, and prequal is faster. So that's worth noting. So here's an example of what the command could look like. You'll notice there's no XNAT label because we wanted to make this available for non-XNAT users as well. So the sub session, the BIDS directory, wherever your BIDS data is found, then the partitions, Slurm partition or other schedule managers just needs to have the name of that partition. And then it does require a free surfer license. QSI prep specifically requires a free surfer license. So those are free to get. You can download those from the free surfer website and just pass the path to that license here. And like I mentioned earlier, the output derivatives are found under the user specified BIDS directory here, and in that same structure that I showed earlier is how it'll show up. And then finally, tandem mode, which is a combination of Git and process mode. So this is only applicable if you have an XNAT instance. If not, then this won't be useful. But hopefully the best of both worlds, that you can, with one command, download your data and then process it and then upload it back to XNAT with its report. So here's an example of what it could look like. As you'll notice, there's lots, it essentially needs the commands that get mode and process mode require. So it's a little bit longer, but if you have an XNAT instance, then this is a helpful way to streamline the process. Okay, so that concludes the how to use DWIQC. I'll pause for any questions or comments here before we move on. We've gotten through the kind of core of DWIQC, and we'll just talk about it a little bit more conceptually now. So I'll go over the strengths and limitations. So there's some things that really stand out as strengths to DWIQC, and that's the flexibility of it, and that's very customizable. So there are some, if you're familiar with QSI prep and prequal, there are lots of optional arguments that you can pass and optional flags you can pass to those pipelines. We have some default ones, and you can see those on our GitHub repository and on the documentation that we thought were kind of a good place, kind of a vanilla place to be for most users. But it's very customizable. You can customize those commands to your needs, your preferences. So that's very helpful. And it's something else that's a part of that, like I mentioned, DWIQC is amenable to several different experimental designs. You don't have to exclude yourself from using it just because of how the design of the experiment was. And that's by virtue of having both QSI prep and prequal as a part of it. We really feel strongly about the landing page on XNAT, that we had experts, the neuroimaging experts and users help us decide what lands there. And it's this data that you're seeing on the landing page, that you see in the reports, it's put through a gauntlet. There's a real pipelines, real processing that's happening. It's not spot check things. If there's problems with the data, it'll get found by running this pipeline. And it's 2-for-1, open source, actively maintained. But one of the biggest strengths, I think, is catching potentially data issues in real time, or issues with the scanner or acquisition problems in real time. Because in a perfect world, data gets archived in XNAT, DWIQC gets run soon after, and it's uploaded within a 12 to 24 hour period of the data being archived. You can catch issues right away. And you know that if something failed in DWIQC along with the other pipelines we have, there's something to take a look at. It's hopefully very helpful in catching issues before they become real issues in real time. Now, some limitations. Best results require GPU resources. Specifically uses CUDA, so that requires an NVIDIA GPU processor. And this is primarily for volume-to-volume motion correction, which many folks feel strongly about, feel is absolutely essential to image processing, and reasonable minds will disagree on that. It can be run without a GPU. There's a command line argument, no GPU, that you can run. It does take longer if you do that, just because of compute time, but you can just change it so that it doesn't do the volume-to-volume motion correction, and it'll run much faster, and it can be run on a regular CPU. It could be a potentially steep learning curve for beginners. There's, unfortunately, due to the complicated nature of diffusion imaging and different experimental designs and all those things, there's a lot that can go into getting this up and running for a group's specific data, their specific study, and all those things. So in our goal to make things customizable and flexible, it did introduce a little bit of complex getting at the speed steps. But we really hope that documentation can help with that, and we are available as resources to get things working for individuals. And something that's always worth noting, this is built on top of QSI Prep and Prequal, which are separately maintained outside of our purview, and bugs happen, changes happen, and that can affect users of DWIQC in a very real way. So that's an inherent limitation here. And then runtime, it can be up to 10 hours to run this completely, even on a GPU. It's not as bad as other processing platforms, but it's considerable time cost. And finally, I just wanted to point out that this, along with any other tool that's meant to streamline processes, it does run the risk of becoming a black box. And so that puts the responsibility on us as developers to make things transparent, and us as users to understand what's going on, understand what's happening with our data. So it's something that we just all share a responsibility in being vigilant in. Any questions or comments up to this point? Okay, so I'll quickly go through. I just want to expose everyone here to the documentation that we have, that I hope is helpful and can walk folks through what to expect. So this is the website, and I'm sure we can include it in maybe an email or on the description of the YouTube video or whatever it is, so that folks can find it. It can be used as a tutorial, step-by-step, of how to do everything from installing to running to errors that come up and what the output should be, all those types of things. Or it can be spot check resources as folks need it as problems come up. And then I wanted to say too that the XNAT tagger package that I mentioned earlier, that documentation is found on the same website. So I'll just quickly go through here. This is what it looks like when you go to the website. And over here, this is where the table of contents is, and everything that is found on the documentation. So if you click on user documentation, you'll find all of this help with running the pipeline. And this expands into step-by-step instructions on all the things we talked about today. And then there's also a resource for understanding the report page in more depth, what's here, why we chose it, all those sorts of things. And then this developer documentation tab is help with installing DWIQC on your HPC or local environment, and then also installing it on XNet, building the plugin, activating the plugin in your XNet instance so that you can see this landing page with all of its tabs and metrics and bells and whistles and such. And then we've got the XNet tagger documentation. If you choose to go that route, this is helpful. This is how to configure XNet tagger, this expanded window, and then running XNet tagger, all these subheaders. So I just wanted to really, I realized that was very quick, but I just wanted more than anything to show folks what's there at a broad level, what help is available to get off the ground with DWIQC. So we'll discuss now some future directions, future plans that we have for DWIQC. We want to, this is potentially the biggest thing on our horizon, is doing something similar to what QSI Prep does and other BIDS apps, is creating this auto-generated HTML report that will hopefully be very similar, look very similar to the XNet landing page that has all those images and metrics and tabs and all those fun things. But it gets all put into one HTML file so that non-XNet users can still have the nice looking report and easy to see, easy to understand, at a quick glance, what's going on with their data. So we have that on our radar. We do want to get this XNet container service figured out, getting out of our dependency issues with prequal and QSI Prep. It'll be quite a technical hurdle, but it's important to us, and we want to get it to the same level as our other pipelines that are integrated with XNet container service. And then finally, we have some custom changes that I mentioned with prequal that we need to fork the repository and then make some changes and create a pull request so that we can get some of these changes integrated so that we don't have to use a customized version of prequal, that we can stay up to date with prequal releases in the future. So that's what's most strongly on our radar. And but now we've got to the end of the presentation. And I'm so glad I could share this with everyone, and I'd love to hear thoughts or suggestions that anyone may have. But most of all, I'm very thankful that I could be a part of this.
Thank you so much, Dan. That was very informative. I know I asked a lot of my questions along the way. So I'll start by opening the floor to others for any remaining questions. If none of those appear, of course, I have questions / comments, types of things to bring up. Within the ReproNim program, amongst our big mandates and pushes is to get as much stuff into containerized types of environments as possible. And so it's great that there's just so many reasons why that's a good thing. And these versioning types of issues that you're aware of, and the forks that are necessary for certain things, keeping track of those is great. One of the services ReproNim works with is also versioning of data. So DataLad is a resource that we do that works about versioning of data. And there's sort of a parallel DataLad universe that does the tracking and version control of containers. So there's DataLad containers extensions that sort of provides an infrastructure and easy to install. A DataLad get container blah, and that does for the same thing as the installs of data or installs of software types of things. So anyway, the statement I'd love to make is at some point in time, it might be good to talk about, if any of the ReproNim container services, are helpful for solving some of your containerized, topics. Without Yarrick here, I can't say too much more specifically about that question, but that's one of the things that I think is a great opening to future types of things to look at. Yes,
that could be very helpful as we try to tackle these problems. We want this to be containerized for all these reasons that you mentioned. So yeah, I think it's a great idea. Felix?
Yes, Felix.
Yeah, thanks for the really detailed overview. I really got an idea what you created, and it's pretty cool. One thing that I think could be is the necessary step. So it begs the next question: as you put both the output in the same environment, to have some cross-reference from the classical numerical output you get on like image quality and errors, and of course, because two metrics on the same images, on the same raw images, is always better, especially if you have different processing of it. So I would say that could be one of the next steps to automatically as well have how reliable basically both quality assessments are. And
Yeah,
I think
so
that generate value directly.
So I really appreciate it. So if I'm hearing you correctly, it's a comparison of the same or very similar metrics across these pipelines, essentially. Is that what you're?
Exactly.
Okay. Yeah, I just want to thank you. Make sure I understand exactly.
I mean, of course, it can go down to the specific quantification of certain metrics of the image, but that's analysis already. As you call it, as it's QC, it's more on the, let's say, more straightforward metrics there. I think that will be similar, and I'm more familiar with QSI prep, so I'm prequel. I will look into it now, so thanks for that as well. But and maybe I'll run it all together with you. Which, in an additional question, if I have already QSI prep run and I have the output, is there a way to basically use that? And I know I understood there's a flag to basically switch off QSI prep, but then have both basically together in the environment of GWIQC. That could be interesting as well if there's an additional, let's say, layer of comparison that I was alluding to just now.
Yeah, so I mean, there's not. It's a really good point. There's not direct support for that right now, because the way that it works, the pipelines get run and they get put into their respective output directories, and then DWIQC will go and pull the different images and metrics and things like that from those output directories and put them into an XNAT artifacts directory is what we call it, and then from there they all get uploaded together. So I mean, I could see to answer, I mean, there's not direct support for just saying, here's my QSI prep output and here's my prequal output, upload them, to XNAT, but you could kind of in a manual way do that. But that's a very good suggestion, because that could be very interesting, where folks have previously processed in one but not the other, and then they still want, if you have an XNAT instance that you can upload to, then I can see that being very helpful. Yeah, that's a great thought.
And the last thing, of course, if you can have a containerized XNAT instance to basically have, even on, let's say, not a large system, but let's say localized in a container, XNAT container, if that exists. I didn't look into that. I'm sorry for that. I used XNAT, but only indirectly, so I'm not really familiar. So I basically have the landing page in the end. Do you thought about this? Or I know that's a larger system, but would that be a possibility as well, to basically generate for a smaller system as well the output that DWIQC is creating in the end?
Yeah, I would hope. I mean, that's part of what we want to achieve, is that it doesn't depend on XNAT or anything like that to have that output. It's very much on my mind, but right now it's not there, but it's very much on my mind. Yeah,
thank you so much.
Yeah, thank you. I appreciate it.
Thank you.
I'll just make notes here of everything Felix was saying so I can remember these feature requests.
It'll always be on YouTube.
Yeah, that's a good point.
Any other questions? Hearing none, I will thank Dan again for his presentations. Very good, very informative.